Good day everyone, I am CUBERO III from 2 BSABE. Now we're gonna solve some sample problem about pure substances. Now, a piston cylinder device with a mass of 12 kilograms and in a diameter of 25 centimeters contains R134A at 88 kilopascal. Heat is transferred to R134A. Now find the final pressure, the change in volume of the cylinder, the change in enthalpy. Now, the final pressure, which is the P2 times equal to initial pressure, which is the P1, is equal to atmospheric pressure plus the mass times gravity over pi times diameter squared over 4 is equal to 88 kilopascal plus 12 kilograms times 9.81 meter per second squared over pi times the diameter 0.25 meter squared over 4 times the 1 kilonewton over 1000 kilogram meter per second squared is equal to 90.4 kilopascal. Now, we multiply it to 1 kilonewton over 1000 kilogram meter per second squared to convert it into kilonewton to to kilopascal, because 1 kilonewton is equivalent to 1000 kilogram meter per second squared or newton. Now, the value for this 12 kilograms times 9.81 meter per second squared is newton. Now we need to convert it into kilonewton, so we get the kilopascal, because kilopascal to plus kilopascal. Now this is our pressure now, 90.4 kilopascal. Now for letter B, the change in volume of the cylinder. Now what we need to find is the specific volume and enthalpy of R134A at the initial state of 90.4 kilopascal and negative 10 degrees Celsius, and at the final state of 90.4 kilopascal and 15 degrees Celsius, or specific volume 1 equals to 0.2302 cubic meter over kilogram. Specific volume 2 is equals to 0.2544 cubic meter over kilogram. Now the enthalpy for the first or the initial state is 247.76 kilojoules per kilogram, and the final state is 268.16 kilojoules per kilogram. Now we need to solve first the initial and the final volume so that we could find the change in volume. Now the initial volume is equal to mass times the specific volume of state 1 or the initial state equals to 0.85 kilograms times the 0.2302 cubic meter per kilogram. Cancel the kilograms, so the unit left is the cubic meter, 0.1957 cubic meter. Now the final volume is equal to 0.85 times the specific volume of final state, 0.2544 cubic meter per kilogram. Cancel the kilogram is equal to 0.2162 cubic meter. Now, to solve for change in volume, change in volume is equal to final volume minus the initial volume, which is the 0.2162 cubic meter minus 0.1957 cubic meter equals to 0.0205 cubic meter. Now, this is our change in volume. Now, lastly, the total enthalpy is determined from change in enthalpy equals to mass times the enthalpy of the final state minus the enthalpy of the initial state is equal to 0.85 kilograms times the 268.16 minus 247.76 kilojoules per kilogram is equals to 17 kilojoules per kilogram. Now that's it. This here is a typo. It should be 1957 cubic meter only, not 11,957. I think here too, this is supposed to be 9.81. It's just a typo. Thank you. That would be all. God bless.